Hi, welcome everyone. Today I'm going to show you a simulation that can discuss the consequences and the possible way to handle heteroskedasticity in your models. So first of all, we start with the example that this is our model y is equal to beta 0 plus beta 1 x into u. Assuming with beta 0 is 0, so we start with a model that there can be two types of variation in the residuals, that is u square, that can be related to X or related to any other Z. Okay, so it can be as conventional OLS and then with robust models available. So heteroscedasticity usually happen when the residuals, the variation are related to X variable. Okay, so what we do is now we see this is a scenario where the residuals are related to X. So you can see when X increases, the scatterness increase. We can shuffle it to apply different seeds. So you can see we can reduce the number of simulations and increase the sample size to see more variation in the data. Okay, in this example, so let it load the data so you can see now. What we can also do is we can change the center of the mean to different position also, so that we can calculate more values. So let's say I change the seed number, so it is still the data here. So this is the data. So now we assume that the true beta is, let's say we say 1.50. Okay, and the scale of standard error is 1, so it's always 1 because you see the coefficient with u is 1. So this is the result. Now we can see the distribution of beta. You can see it's still there. So this shows that with heteroscedasticity does not create a bias in the slope because it does not change the population, the estimation of the standard slope parameter. But when we go down, we can see that the probability that we 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 reject the null hypothesis. Okay, so it is insignificant here. So what does it mean is that in the conventional, if there is heteroscedasticity, we are not able to find the significance that the beta 1 is actually greater than 0. But for the case of other the heteroscedasticity consistent standard error methods at CO1, 2, 3, you can see at 10% they are significant. Okay, so we also see that the distribution of p-values. Okay, this is their count. So you can see that here it is so if it is ideally it should be flat, means across so the number of counts should be similar across all the probability numbers. Now we need to see power curves. The power curve will tell us that how does the heteroscedasticity disturbs the estimates. So you can see that, let me make it better. So if I come here, the curve should start from, let's say, 1 and should end at 2. Okay, so that you can see. So if you see, if I remove the other standard estimates, you can see that the distribution, the probability curve of simple regression at the true beta is at 0.27. So it means that if there is heteroscedasticity, our model is not able to reject null hypothesis at the true beta. Means we are not able to accept the beta is significant. So our estimates are not able to uh, estimate the true coefficient. Okay, and then you can see if I remove this and if I estimate any other standard error estimate at C0, you can see at the true beta it is able to estimate even at least at 10% level. So it is able to uh, acknowledge that there is a significant beta. Okay, so we can check all of them. Okay, so it also shows that our estimate values are here. So So you can see the estimate values. If I add all of them, you can do the comparison. So this activity is actually showing that if we have heteroskedasticity in our estimates, what will happen is that it will increase the standard errors, and it will because of the variation of the residuals. The model, even though it has a true central tendency, true point estimate, but it will not be able to acknowledge it as a significant effect. So, uh, so if you have a regression model where there is heteroscedasticity, you might not be able to reject the alternative hypothesis, which was technically true if there is no heteroscedasticity, which we are able to see when we apply other estimation methods. Okay, so this was the purpose of this activity, to show that how robust methods are able to make sure that you estimate, you are able to acknowledge a true hypothesis. Thank you.